In this example, we will evaluate the antiderivative of 1 over the quantity x squared plus 1 raised to the 3/2. Now, looking at the form of our integrand, this isn't something we could easily handle with integration by parts or substitution. But this quantity x squared plus 1 in the denominator is really indicating to us that a trig substitution might be appropriate. Because of the form x squared plus 1 squared, the trig substitution that we would use is x equals 1 tangent theta. And what we would like to do is plug this into our integrand to get a equivalent, hopefully easier to evaluate trigonometric integral in terms of the theta. So we need to replace the dx. dx is secant squared theta d theta. So rewriting our integral in terms of the variable theta gives us the integral of 1 over, replacing that x with tangent, we'll have the quantity tangent squared plus 1, all raised to the 3/2, and dx is secant squared theta d theta. So we've applied our trigonometric substitution, we've expressed our integral in terms of an equivalent trigonometric integral. And once we do this, our first step is always going to be to simplify the integrand by applying a corresponding trig identity. And here the corresponding trig identity is that tangent squared plus 1 is equal to secant squared. So this will be 1 over the quantity secant squared to the 3/2 times secant squared. And when we take that secant squared in the bottom and raise it to the 3/2 power, what happens is the square with the secant and the 1/2 with the, associated with the 3/2 power cancel each other off. So we end up with the antiderivative of secant squared over secant cubed. So that would be the integral of 1 over secant, or more simply, just the antiderivative of cosine. The antiderivative of cosine is sine, so we end up with a sine theta plus c. Now, anytime we're evaluating an indefinite integral, we need to go back and think about what that original variable was, x. So our solution needs to be expressed solely in terms of the variable x. In order to do so with a trigonometric substitution, the suggested method is to draw an associated right triangle. So our trig substitution is x equals tangent theta. So let's draw the associated right triangle. If we have a right triangle, an angle theta, to say tangent of theta equals x, we could label opposite side x, adjacent side 1. Once we do so, we'll always have a third side of the triangle to label. Here the hypotenuse, and it would be, via the Pythagorean theorem, square root of x squared plus 1. And note that the quantity or expression here under the square root, the x squared plus 1, is the quantity that really prompted us to use the trig substitution in the first place. And it will always work out that way. So now we say, well, what's sine of theta? Well, looking at our right triangle, sine of theta would be x over the square root of x squared plus 1.